Hello class, today we are going to look at properties of polygons. Alright, so let's take a look. First off, we want to know what is a polygon, right? Well, hopefully you remember a polygon is a shape that is made up of straight sides. That's it, polygon. No curves, straight sides. And it is a polygon. It's two-dimensional, not three-dimensional. Okay, so let's take a look here, a couple definitions. First off, we have equilateral polygons, just like we had equilateral triangles. A triangle is a type of polygon because it has straight sides. But we have equilateral polygons. These are polygons that have all the sides are congruent, like this one right here. All right. Notice the sides are congruent, but the angles are not. So this is an equilateral hexagon. All the sides are the same length. We also have an equiangular polygon. An equiangular polygon, all the angles are the same. We're specifically looking at the interior angles, these ones that are marked there in this polygon. Notice all of the angles are the same, so this is an equiangular hexagon, but the sides are different, so it is not equilateral. Remember, with a triangle, if it was equiangular, it was equilateral. Not true with other polygons, only for triangles. Now, if it does work out that it's equiangular and also equilateral, we call that a regular polygon, like this right here. So this is a regular hexagon because all of the sides are the same, all of the angles are the same, so it is regular. And this is what you think of normally when you think of a hexagon, or if you think of pentagon, you think of the regular pentagon, the regular hexagon, right? What does an octagon look like? You think of a regular octagon that makes a stop sign, right? Okay. One other definition I do want to talk to you about really quickly, and that is an n-gon. An n-gon. What an n-gon is, that is just a polygon with n sides. All right. All that is a polygon with n sides. All right. So technically these three right here, they have 6 sides. We could technically call them a 6-gon. All right. Please don't. Please continue calling it a hexagon. But if it's got more than 10 sides, people don't know what they're called, and so you can call it a 27-gon. That's fine. Instead of looking up what do you call a 27-sided polygon, you can just call it a 27-gon, and you're good. All right. So there's some definitions. Now let's get into some properties of polygons. Specifically, we're going to look at angles. So, interior angles of a polygon. The interior angles, remember, those are the angles on the inside of the polygon. All right, so let's take a look at it. First, we have this polygon over here. This is a triangle. Here it has n is 3, right? And what do the angles of a triangle add up to? Hopefully everybody remembers this. It adds up to 180 degrees, right? So what about this next one, this quadrilateral, where n equals 4? In a quadrilateral, what do those add up to? Well, I don't know, but you know what? We can take this quadrilateral and go like that. Now I have 2 triangles, right? Each one of them is 180 degrees, so that's 2 times 180, so this would be 360 degrees. Okay, so what about over here, the pentagon, where n equals 5? Well, I don't know. You know what? I can make that a triangle too. I can just go like that and like that. Now I have 3 triangles, so that would be 3 times 180. So 3 times 180, that would be 540 degrees. Okay, so the next one on here, let's see how many sides do we have here. We have 1, 2, 3, 4, 5, 6. So n equals 6. So this is a hexagon. Clearly it is not a regular hexagon. It does not look anything at all like this right here, right? But it is a hexagon. Well, you know what? I can make triangles out of that too. I can go like that. There's a triangle. There's a triangle. There's 2 more triangles. So I have 4 triangles. Each one of those have 180 degrees. So 4 times 180, which would be 720 degrees. All right, so let's take a look at this last one here. Very irregular. All right. So let's see, can we make triangles out of that? We got a triangle there, we got a triangle there, triangle there, triangle, triangle, and two more triangles. So let's see here. We have, how many sides do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. So n equals 9. And how many triangles do we have? We have 1, 2, 3, 4, 5, 6, 7. We have 7 triangles. Each have 180 degrees. So 7 times 180 is 1,260 degrees total. Now, if you'll notice, every single time when we did this, we just multiplied by however many triangles we had, right? And if you'll notice, when I had 3 sides, I had 1 triangle. 4 sides was 2 triangles. 5 sides was 3 triangles. 9 sides was 7 triangles. In each case, you'll notice the number of triangles is 2 less than the number of sides. And so this gives us a formula right here. The sum of the interior angles will be 180 times n minus 2, where n is the number of sides. So if we had 33 sides to our polygon, then we do 33 minus 2 is 31 times 180, and that would tell us how many degrees the interior angles added up to. Also, I want to point out that it does not matter if the polygon is convex, like these, or if it's concave, like these. Remember, convex, all the angles poke outward. Concave, they cave in like this. So right here, it's caving in. All right? It only takes one concave angle to make the entire thing concave. All right? And so here we see it doesn't matter if we have a concave polygon or a convex polygon. The formula works either way. All right, so that will be interior angles of a polygon. Now let's take a look at exterior angles of a polygon. Okay, so for exterior angles, I have this right here we're going to look at. And so we have, how many sides do we have on this thing? 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 sides on this polygon, right? There we go. N equals 9. We like that. And so notice if I take this angle and I pull all of these angles in together, notice what happens to these exterior angles. They come together and they make a circle, don't they? And what is the measure? How many degrees are in a circle? Yeah, it's 360. Okay, so you know what? Let's take this. Let's move this down to 7 sides. Heptagon. Bring these in and look at that. It's still a circle, right? Okay, what if I go all the way down here to a triangle? Bring it in, and all of those angles come together, and we have a circle again, right? Well, let's see, what if I move my triangle out like this? Let's do that. Change my triangle. Does it still work? Oh, I don't want to do that. I want to do this. Ah, it still works. Still a circle. Still 360 degrees. Okay, let's put these back. Oh, I moved those, so I'm not. Okay, let's grab that. Give me that. There we go. So, let's see that. And it all comes together. So, even though I've got them all wiggled around, it still works. Now, this does not work for everything. Notice this. Watch, I'm going to do this. I'm going to make this one concave. Notice I've got the angle on the inside here. Now, when I bring them together, I've got some overlap, don't I? That one overlaps right there. So, that's no good. So this doesn't work if we have a concave polygon, but it does work for any convex polygon. So if you have a convex polygon, it doesn't matter how many sides it has or what where those sides are or how it looks, as long as it is convex, the exterior angles of the polygon will add up to 360 degrees. Right? And the reason that works, think about it, if you start here at point A and you're driving in a car, you turn to the left, and you turn to the left, and you turn to the left, and you turn to the left, you turn to the left, you turn to the left, and you've just gone full circle right back at A, right? And it's all turning the same direction, so eventually you've turned 360 degrees, and you end up back where you start. So, for exterior angles of a polygon, what we are going to write down is that they always add up to 360. Well, I say always, as long as it is convex. Exterior angle of any convex polygon will add up to 360 degrees every single time. All right, so let's do a couple of examples with this. Let's see what we got here. Okay, find the sum of the measures of the interior angles of the polygon. So we have an octagon, and let's just real quickly let's write down our formula for this. So the sum of the interior angles is equal to 180 times n minus 2. Okay, so for an octagon, what we need to know is what is n? Well, it's an octagon. It has 8 sides, so n equals 8. So what we're going to do is we're going to come over here. Sum is equal to 180 times n, which is 8, minus 2. And we take that and you stick it into your calculator. So let's see here. That would be 8 minus 2 is 6. So 6 times 180, and we get 1,080 degrees. Okay, so I would like you to pause the video and you do number 2. All right, let's take a look here. So on number 2, what is n? N is 24 right there. So it's a 24-gon, so n equals 24. So we're just going to take 24 and plug it into our formula. The sum is equal to 180 times 24 minus 2. All right, so 24 minus 2, that's 22, and you stick it in your calculator, 22 times 180, and you get 3,960 degrees. And there you go. Easy peasy. All right, just plug it into the formula. All right, let's take a look at some of the things. The sum of the measures of the interior angles of a polygon is given. Classify the polygon by the number of sides. Okay, so again, it gave us the sum, which means we are using that same formula we used a minute ago. So I'm going to write it down here. The sum is equal to 180 times n minus 2. All right. And all we're going to do is just plug in what we know. We know the sum, 900, equals 180 times n minus 2. And we're just going to solve this for n. So first, we're going to divide by 180 on both sides. Divide by 180, divide by 180. And so we end up with 5 equals not n. It equals n minus 2. So you add 2 to both sides, add 2, and we end up with n equals 7. Now, the question says to classify the polygon. When it says classify, that means what's its name. All right. So if n is 7, what do you call a 7-sided figure? Well, hopefully you remember that this is a heptagon. Heptagon. And that is the solution. Technically, you can call it a 7-gon. That's fine. Heptagon is better. All right, so pause the video and you do number 4. All right, hopefully you got it right. Let's take a look and see how you did. First, we're going to plug into our formula. So 2,880 equals 180 times n minus 2. We're going to divide both sides by 180. And so that gives me 16 equals n minus 2. 16 is not my answers. All right, you got to do n minus 2. So we're going to add that 2 to both sides. And so I have 18 equals n. And what do you call an 18-sided figure? Yeah, you call it an 18-gon. That's more than 10, so 18-gon is fine. Notice it's 18-gon. It is not an 18-a-gon. There's no a there, just 18-gon. All right? All right? Or you can call it an octadecagon if you really want to impress your teacher. Okay, so let's take a look at the next thing. Find the value of x. Okay, where's x? There's x right there. X is right there. So we need to find the value of x. Let's see, it gives us some angles. So, all right, so what we need here, we have all of the angles except for one. So if we know what they all add up to, we can just subtract what we have, and x is what we'll be left with. but it's not a triangle, so we have to figure out what do these all add up to. Well, let's see here. We have 1, 2, 3, 4, 5, 6 sides. So let's just plug it into a formula. S is equal to 180 times 6 minus 2 minus 2. Okay, so 6 minus 2 is 4, so 180 times 4 is 720. So S is equal to 720. So all 6 of these angles are going to add up to 720 degrees. So let's see what we got. We got 140, 130, 120. That doesn't have a number, but it's a right angle, so we know that's 90, and 150. All right, so that's 0, and 2 and 3 and 5 is 10, and 14, and 23. So 23, so 2, 3, 4, 5, 6. There we go. 630. So we're going to subtract 630. And let's see, that's a 6, that's a 1, 12 minus 3 is 9. 90 degrees. There we go. So X equals 90. That's not too bad, right? Not too bad. All right, let's do one more example. All right, these are on the outside. Okay, so how many sides do we have? Well, it doesn't matter, does it? Because they're all on the outside. And if the exterior angles, what do they add up to? 360 every single time. Now, this one is a little bit more complicated because I got 4x over there and x over there. So I'm just going to write this as an equation. So let's see. We have 4x plus 98 plus x plus 162 equals 360. And it's 360 not because it's a quadrilateral, but because they are exterior angles. It could be 1,000 sides, and they would all add up to, the angles would add up to 360. Okay, so let's combine like terms. We have 4x and x, that's 5x, plus, let's see here, 162 and the 98, which is going to give me 260 equals 360. Subtract the 260 from both sides. And so that cancels out. And I've got 5x equals 100. Divide by 5, divide by 5. And x equals 20. All right? And there we go. Not too bad. So just to recap real quickly, back up here. Exterior angles of a polygon, as long as it is a convex polygon, I probably ought to write that down. Exterior angles of a convex, right, which means like this, right? Convex, or there's a convex hexagon. The sides all poke out, not a concave. This, no good. Convex. Convex polygon exterior angles all add up to 360. All right? That's these angles right here. Always add up to 360. Interior angles of a polygon, we use the formula right there. And on this one, it doesn't matter if it's convex, like these two here, or if it's concave. Notice it caves in, right? That makes it so. Concave doesn't matter. Formula works for any polygon if it's interior. And a regular polygon has sides and angles congruent, and an n-gon just means it has n number of sides. All right? Please don't use n-gon if it has 10 sides or less. Call it by its name. Octagon, nonagon, quadrilateral, pentagon, triangle. Please don't call it a three-gon. But if it's got more than 10 sides, you can call it an 11-gon. You don't have to call it a hendecagon. You can call it an 11-gon or 27-gon or 3,762-gon, right? And it's just gon, right there, gon, no A. All right. Hopefully you found that useful, and I will see you in the next video.